So returning to looking at functions and things like that, and you may recall when we were looking at the basic curve, I said, oh, and any type of quadratic can be transformed from the basic parabola, or any type of cubic can be transformed from the basic one, and so on. So let's have a look at these transformations, and the first one, translating. So translating is when we slide. So a horizontal shift, if we're looking at the function, it's when we replace the x with x minus h. So it becomes y equals some function of x minus h, and that'll represent a horizontal shift, either left or right, depending on whether it's positive or negative, h units. If ever you're unsure how it's shifted, to work out where the origin has been moved to, solve x minus h equals 0. Whatever the answer is, then that's where 0 has been moved to. Vertically then, well, that's to do with the y values, it's the range that's going to be affected. Same idea, we replace y with y minus k. I think it's better to think of it that way. That's what we get. So that way the idea is the same. So to do horizontal, we replace x with x minus the shift. To do y, we do y minus the shift. In reality, we then would move the k to the other side, and we see it as y equals function x plus some constant number. But if we think of it like that, and then it's nice and consistent. So up or down, depending again whether k is positive or negative. And also, if you're unsure, you want to find where 0 has been moved to, solve what y minus k equals 0 gives. So let's have a look at one. So I see something like this, x minus 3 squared plus 4. Well, the squared there's telling me it's our parabola. So the basic shape is y equals x squared. So what have I done to it? Well, the first thing I notice, grouped with the x. And that's the key. If it's grouped with the x, it's a horizontal shift. So x minus 3 tells me I've shifted it right 3 units. Now, the next thing we notice is the plus 4. Well, that's like saying y minus 4, but it means we've shifted it up 4 units. So there's our new position. And so the vertex, of course, is now at 3, 4 instead of 0, 0. X squared plus 2x plus y squared minus 4y minus 4. Well, I know it's a circle. We know it's a circle because the x is to the power of 2 and the y is to the power of 2 as well, and the coefficients are the same. But before I can work out the shift, I need to complete the square. I need to complete it on both the x and the y though. So remember, it's half the coefficient of x, so we get plus 1, but the same deal with the y, half the coefficient of y, so we get minus 2. And that means that I've added 1 for the 1 squared and 4 for the minus 2 squared. Along with the 4 we already had, we get 9. So the basic curve is x squared plus y squared equals 9. We know that's a circle, radius 3. Grouped with the x tells me I've shifted it left 1 unit. I'll move it there. This time it is grouped with the y. Grouped with the y tells me I've shifted this one up 2 units. And so the centre is now at minus 1, 2. I didn't actually label what the radius was. I probably should have done that. So the radius is 3 units, of course. 2x squared plus 8x plus 5. Y over 2, because when I complete the square, I prefer it to be 1x squared rather than 2x squared. I just find that easier. So I'll rewrite it as y over 2 is x squared plus 4x plus 5 on 2. Then half the coefficient of x is 2. So I know I've got x plus 2 all squared, but now I've added in an extra 4. So I'll take away the 4 there to balance it out. We get y on 2 is x plus 2 squared minus 3 on 2. Now I'll multiply back by that 2 so I can get it as y equals. And y equals 2 outside of x plus 2 squared minus 3. We can see what's happening. So it's the basic parabola again. This time, the 2 in front of the x plus 2 squared makes the curve steeper. So I know it's going to be steeper. We have a horizontal shift. We're going to move this one left, negative 2. Oops, slide it across. And we're shifting it down 3 units this time. And so there's my new parabola. Okay, so that's translation, so the sliding. Reflection is another way we can change our curve. So with a reflection, depending on which way we want to reflect it, if it's a vertical reflection, I replace x with negative x. So it's y equals function negative x. That'll reflect in the y-axis, so a vertical reflection. By the way, a quick way, when you see something like this, if you want to reflect in a different line instead of the axis, then replace x with 2a minus x. So if you want to replace in the line x equals a, that's going to be your reflection line. then replace it with 2a minus x, and that'll get a reflection in x equals a. Just to show you why. There's y equals function x. If I was to reflect it, so there's function negative x. I always get horizontal and vertical the wrong way around on this. That's a vertical reflection. Yeah, because you're reflecting in a vertical line. Now I'm going to translate it 2a units to the right. But if you have a look, I'll just dot in x equals a, that actually becomes a reflection in the line x equals a. So it's like combining two of the transformations in one hit. So function 2a minus x will do that. Okay, horizontal, same idea, but now it's the y values we're concerned with. So we'll replace y with negative y. So negative y is function x, although we probably normally see it as y equals negative function x. But same idea, we'll keep it with the y to highlight. Yep, that's what we're affecting, the y values. That will reflect in the x-axis. Similar idea, if you wanted to reflect in a different horizontal line, then replace y with 2a minus y. Let's have a picture of that. There's function x, y equals minus function x, reflect it. Now I'll shift it up 2a units. Again, I'll just dot in a, and you can see that actually, yes, effectively, I've just reflected in the line y equals a on that one. Reflection in the origin. So that's y equals minus function minus x. So both the y and the x are becoming negative. That's actually a rotation. So if you rotate something 180 degrees, that's the same as reflecting both vertically and horizontally. Here's random curve. Function x, slide across. If I reflect in the, hang on, which one have I done first? I've reflected in the x-axis first. That's, oh, get it right. That's a horizontal reflection. So therefore it's the y values we're affecting. So that becomes minus y equals function x, or y equals minus function x. Now let's do the vertical reflection of that shape. And so now we replace x with minus x. So that would be y equals minus function minus x. Now if you compare the very first graph to the last graph, you can see, oh, actually in reality what we've done is we've just spun that around the origin 180 degrees. So rotation, that's rotation. All right, so what would this look like? Y equals minus x plus 1 cubed plus 2. Okay, it's based on my beautifully drawn basic cubic there. A little bit dodgy, okay. But that's my cubic. I see the negative, in reality it's with the y, because it's not grouped with the x. It's outside the parentheses. So that negative is referring to the y. So that must be a horizontal reflection. Now, grouped with the x, we have the 1. So we have a horizontal shift left 1 unit. There we go. And then we've got the plus 2 over there as well. So we shift the whole thing up 2 units. And there's our graph. So the origin has been moved to minus 1, 2. Y equals minus 2 to the power of minus x. So this one, both the y and the x value we've made negative. So that's our rotation of 180 degrees. So there's our basic exponential curve. We're going to rotate it 180 degrees, or reflect it in the origin. And we'd end up with that. There's our